Hi everyone, I'm Nan, and welcome to the first chemistry class. It's general chemistry. And first, let me introduce myself. I am a volunteer in the Youth Promise, and I'm 16 years old, and I'm from China. Now let's start the class. I will share my screen. And sorry. Before we are talking more deeply, I want to give you a very quick introduction about what is chemistry. Chemistry is the study of composition, properties, and interactions of matters. And matters are material substance and that occupy space and has mass. Actually, all the things that have temperature are be considered matters. And in chemistry, there are basically three common states of matter. They are solid, liquid, and gas. And if you look them in the molecular form, it looks like this. Solid particle is well organized and close to each other. And liquid is still close to each other, but it's not organized. And gas, as you can see here, there are a lot of space between each gas, and they can run everywhere, the particles. And then I will introduce some characteristics about the state of matter. For the solid and liquid, the volume are fixed, which means even if you change a container, like make the container bigger, their volume will stay the same, but not change. And for gas, the volume is variable. Like if you put some gas into a bigger bottle or something, the gas will expand. And the shape of solid is fixed. However, the shape of liquid and gas is both variable. Like if you put water in a different shape of container, it can change the shape, and the gas is the same. And the distance between solid and liquid particles are close, just as I mentioned before. And the distance of the particles, each particles of gas is very far apart. And the motion of the solid is vibrational, and just like this, they will stay at the same place and vibrate. And just imagine penguin. When in winter, they squeeze together because each penguin are very close, just like each particles of the solid. So when penguins squeeze together, they cannot they cannot move to anywhere. They can just squeeze together. And both for the liquid and gas. And liquid and gas, they are also vibrational. Actually, I make a mistake in my previous talking. I said all the things that have temperature are be considered matter. However, that's wrong. And what I want to say is that all the matter that have temperature are moving like vibrational. And the speed of solid is very low, and the speed of liquid is moderate, and the speed of gas is very high. And for the energy, the solid have the lower energy because its particle cannot move to anywhere, so it's hard to have some energy. And the energy of liquid is moderate, and the energy of gas is high. Just like when you boiling some water, in the ice cube there are less energy, so you can feel that the ice cube is very cold. And after the ice cube melting to the water, the energy will rise up because it absorbs energy. And after the liquid, become being steam and evaporate, you will feel like the mm, sorry, you will feel the steam is hotter. Actually, it's hotter than the normal water. And then there are two important concepts that you need to know. They are physical and chemical, and they are characteristics that allow us to distinguish one substance from another substance are called properties. And physical properties are any characters observed or measured without changing the composition of matter. Just here are some examples: density, melting point, hardness, and magnetism. Just imagine that, like, you have one rock, and the hard is that hard you touch it. However, you have another rock, it's still hard, so it will not change the composition of the matter, even if you have like the more mass of the rock. And then we are talking about change. And a physical change is where the state or properties of matter change without altering the fundamental composition of the matter itself. And just like the solid change, just like the changing in the state, like when solid melt into liquid and liquid boil into the gas. Take water as example. Its composition will still be H2O, and just the state change not means the composition, like what is made of change. And here are some examples of the physical change. They have melting an ice cube, boiling water, mixing sand with water, breaking glass, and cutting paper. Like you can notice that even if the shape of the glass or paper change, but its composition is still same. And crushing a can, mixing green and red marbles, dissolving sugar in water. And then I'm going to talk about chemical properties and change. Chemical properties describe the ability of a substance to change into different substance. And a chemical change is the process of forming a substance that has chemical properties. And take iron as an example. The property about the chemical properties of iron is that it will rust when it meet with the oxygen. And the chemical change is the, the observation that you you observe it, you observe it have rust. And also for the chromium, the chromium's chemical properties is that it will never rust. And here are some examples of chemical change. Include burning woods, because you burn carbon and combine the carbon with oxygen to get CO2. So its chemical composition change from carbon and oxygen and combine to the carbon dioxide. So it's chemical changes. And fireworks, because you need to burn the fuel. And roasting banana, metabolism, cooking eggs and dissolving salt. I think you may think very strange that dissolving sugar is a physical change, but why dissolving salt is a chemical change? That's because the different composition and different organization about these two matters. And I will show you here. Just like here, you can see the sugar is combined with different crystal, and actually each crystal is just like a lot of small crystal combined to a big crystal. And when the water molecular crash the whole sugar, it will not like break down to different composition or different element. It will stay the same, but just break to the smaller crystal. However, the composition of the salt is very different. Like it's sodium chloride, and it's combined with the sodium ion and chlorine ion. And when the water molecular crash the salt, it will divide it by the separate sodium ion and chlorine ion. So it not maintain the same. It's not sodium chloride anymore. And now I want to give you some time to ask you a question. Do you think grinding coffee beans is physical or chemical change? Okay, I hope you get the right answer. Actually, grinding coffee beans is physical change because you just make the coffee beans smaller and to the powder, but you didn't change any composition about the coffee beans. What about a silver knife that is tarnishing? Yes, you are right. It's chemical change because it's it's just like rust. The silver combines with the oxygens to form something, so it turns black and have different composition. And then I will introduce you to different concepts. They are to another different concept. They are extensive and intensive. And extensive properties is dependent on how much matter there is, which means the intensive properties will change if you have more mass of one matter or less mass of one matter. And here's an example. It have volume, mass, length, and heat. And just imagine that if you add more water to one bottom, the volume will change. So that's the great example about the extensive properties. And intensive properties is independent on how much matter there is, such as density, hardness, melting point, and temperature. And just like boiling water, if you have 100 kilograms of water, you are boiling it. The boiling point is still 100 degrees Celsius. And if you boiling like much more water or much less water, the boiling point will not change. And you may think it's very strange that why heat and temperature are considered different. And first, I will show you what's the definition about heat and temperature. Heat is a form of energy. To make an object hotter, you must add heat, and to make an object colder, you must remove heat. And temperature is a measurement of how much heat a substance contains it in that instant. Please notice that you need to pay attention to the instant. And we always use the thermometer to measure it. And just consider a situation when you are melting ice cube. And if you just melting one ice cube, you need less heat. But however, if you melting like 10 ice cube, you need to have 10 times more heat to absorb in the ice cube in order to melt it. However, if you use a thermometer to measure the temperature will stay the same as 0 degrees Celsius before you before it all melting, so that the heat is changing with the mass. So it's an extensive properties. However, the temperature will not changing if the mass change, so it's an intensive properties. And then I will introduce energy. Energy is changes. Both chemical and physical are accompanied by changes in energy. And energy is the ability something has to do work. And there are two types of energy. There are potential energy and kinetic energy. Potential energies is the energy due to an object position. Like if you put an object higher, it will have higher potential energy. And the kinetic energy is the energy due to an object motion. Like if you move a subject faster, it will have higher kinetic energy. And here are actually just one rules in looking at energy, is that energy is conserved, which means the potential energy plus kinetic energy is constant. Like the two energy can transfer to each other, but the totally energy are always stay the same in the universal. It will never like have some new energy or have less energy, because energy are transferred to another object, but it will not like be create. Just take like when you pulling a ball from the third floor of the buildings, and when the ball falling onto the ground, it will accelerate. And at this process, because the ball is falling, so its potential energy will decrease. However, the potential energy will transfer to the kinetic energy because it's accelerates, so that the speed is faster and faster, so that the kinetic energy is faster and faster. However, because the potential energy is decreased and kinetic energy is increased, so so when they pass to each other, they are still constant. Okay, I think that's today's of our class. And today we introduced the state of matter and the differences between chemical and physical, like includes the properties and change. And we also introduced the extensive and intensive properties. The last things we introduce is the energies. Like there are two kind of energy. They are potential energy and kinetic energy. I hope you are enjoying today's class, and see you next time. I think I will see you very soon. Thank you. Bye bye.